Hi everyone, my name is Elizabeth Burgoyne and I work at ID Technologies, and welcome to our first ID Tech Talk. On this podcast, we're going to explore how technology affects our lives and how it works from a more layman's term like myself. And we have two great hosts. We have Bryan Courtright, who is the Director of Engineering at ID Technologies, and Ari Berman, who is the CEO of BioTeam. I will let them introduce themselves and we will get right to it. This is a more kind of casual podcast where it's two smart people talking about topics that really affect everyone day to day. And so Bryan, I will let you talk a little more about your intro and then Ari will follow.
Thanks, Liz. So Bryan Courtright, I work for ID Technologies. I basically have a small group of engineers that work for me. And together with ID Tech, we do some interesting stuff. We build large computer systems that help keep airplanes in the air. We let the military analyze satellite imagery. We help scientists conduct their research, and then we do a whole lot of other things in between. But essentially, that's what ID does. Ari, take it over.
Great. Thanks, Bryan. Thanks, Lizzie. Appreciate it. Excited to be here. So, Ari Berman, as you said, I'm CEO of BioTeam. BioTeam is a scientific consulting company. We work to empower scientists and IT at science organizations by utilizing advanced technologies and data strategies. So really what we do is we try to bridge the rather large gap between IT and scientists in a way that allows the whole organization to move forward and allows scientists to utilize very advanced technology to advance their research programs. So basically what we like to say we do is we make science go faster. And, we do that through applying strategies, advanced technologies, IT services, scientific research, technical, operational, and data strategies to help that happen. So personally, my background is both in science and technology. So I have a PhD in molecular biology, and I'm trained as a neuroscientist. I did 15 years of laboratory research and 5 years of computational research, using these advanced technologies to try to help with neurodegenerative diseases like Alzheimer's and Parkinson's. At the same time, I also have 28 years of experience designing, building, and operating high-performance computing environments and high-performance scientific computing environments and software to help accelerate science. And that's basically what we do here at BioTeam. So,
thank you, Ari. And just as a side note, my job as a moderator is to rein in the nerds and the nerd talk in case we need to put them in check. To make sure that people like myself and other can actually understand what they're talking about. So Ari, would you mind bring up the topic for today's discussion, and we will go from there. I appreciate it.
Sure. Thank you very much. So the focus of our conversation today is the magic of artificial intelligence and machine learning, also known as AI/ML. Why is it such a hot topic? Where is it useful? Where isn't it useful? What are real life examples of how it's really helpful? For instance, in COVID. And where is it having a hard time being useful? Things like autonomous vehicles. And you basically can't go 10 feet in the tech or science world without hearing AI/ML these days. Everyone's running forward with artificial intelligence. And in my opinion, AI/ML, while super helpful, has been super overhyped. And it's been a marketing dream for vendors like NVIDIA, Intel, AMD, commercial cloud providers like Amazon Web Services, Google Compute, and Azure, Microsoft, and had spun off a number of ML-focused accelerator companies. So is it useful? Yes. Is it the holy grail? Not even close. Bryan, what do you think?
Yeah, Ari, you're absolutely right. I couldn't agree more. AI, it has all of this promise and it has all of this marketing hype behind it. You see firewall companies claiming that their firewalls are AI based, and somehow that's magic and it's going to make the firewall prevent all kinds of penetrations and you will be completely safe. really, we look at this and AI, it's not generalized yet. It's really task specific. And in the right tasks, it makes a tremendous amount of sense. And, we also see AI being somewhat flexible. You'll build a system that's pretty specific. Like Department of Energy is a great example. They build these big supercomputers with all of this AI and machine learning capability. And they're designed to do things like material science and make sure that a nuclear bomb goes boom when it's supposed to go boom and it doesn't when it's not supposed to. And then some interesting stuff happens. COVID comes along and Department of Energy took all of these systems and they retasked a lot of them to do COVID research. And that was spectacular. But you're still talking a couple of pretty specific tasks. So AI isn't the panacea. And I hate to quote Gartner, but Gartner's got some pretty interesting insight on this too. One of the recent articles I looked at said between 2021 and 2023, 50% of AI projects are going to fail. That's staggering. And they attributed that to unreasonable expectations. And this isn't society. These are CEOs writing multi-million-dollar checks for AI projects. And they really don't have a good expectation of what it was going to do. They don't know what it's going to cost. They don't know how hard it is. They don't know whether or not they have people on staff that have the skill sets that they need to make a project successful. So we look at this world and we look at this environment, and AI has all of the promise, but it also requires a lot of work, and it is not simple. So again, I couldn't agree more.
Those of you are muted.
Bryan, I appreciate your response. I just want to take a quick step back for people who may not, I know different definitions for a lot of people, but AI, artificial intelligence. Do you mind just kind of taking one step back, and to both of you, what is the definition of that? What does that mean, and at least in the context you guys are speaking? So
That's
I know
where
it's a huge topic in itself, but
that was where I was going to go next, actually. So thank you for that prompt.
Minds, don't mind me.
That's good. Yeah. So so I sort of view AI ML as sort of becoming the gluten-free tag of the tech world right now. You put gluten-free on something, you can charge more for it, whether it ever included gluten or not, including things like sponges. And so, I think we're sort of there in this space. But okay, so what is artificial intelligence? Okay, it is not Skynet. Okay, it is not this superhuman technology that's going to take over the world and destroy us. It's not the Matrix. And it's unlikely that it ever will be in its current incarnation. So artificial intelligence specifically is a class of mathematical models that are self-determining to a degree and can find patterns or make decisions and perform reactions from input data. Machine learning itself, ML, is a subset of artificial intelligence. Along with other subsets of artificial intelligence, including natural language processing like Siri, Alexa, and Google, expert systems like knowledge bases and semantic searches, speech, like speech to text that you use on your phone all the time, that's an artificial intelligence system, computer vision, being able to steer things automatically and recognize environments, planning, and robotics, like robotics-assisted surgeries, things like that. Those are a lot of different areas of AI. And then what everyone is really talking about these days with regard to AI and ML is a subset of even machine learning, and it's called deep learning, which is an application of a machine learning technique called neural networks. Neural networks are sort of algorithms designed around theoretically how our brains work, but deep learning basically takes that neural network framework and piles them on top of each other so that you can go deeper, build a deeper model to infer or make interpretations from data. So that's what everyone's really talking about these days when they're talking about AI ML, is a subset of AI called deep learning.
Okay, perfect. Thank you.
Bryan, anything to add?
Yeah, so really, we look at this and it's really about computer learning, right? And in computer learning, It's supervised and unsupervised. Supervised learning is taking a set of data and it's telling the computer this piece of data equals this, and this piece of data equals this, and you run millions of those through, and suddenly you get a computer system that's able to make inferences on its own based on that learning. Unsupervised learning is exactly that. The user, the human, isn't inputting this picture of a cat is a cat. They're just running through lots of pictures of cats. And then maybe that computer will be able to recognize, well, that picture isn't a cat, that's a dog. And you basically be able to pick up pattern matching. So those are, the two main types of learning that sit behind or underneath machine learning. And that's a lot of what we're doing today. I think I've oversimplified it to a degree, but at a high level, that is what machine learning and deep learning is looking at right now. Ari, what did I miss? You can pick up on the things that I've missed.
Oh, you almost took the words out of my mouth. So yeah, that's perfect. You have to train these deep learning algorithms, which means you need to give it data that describes the problem you're trying to solve or make inferences from. The cat picture is a perfect example. If you give the computer a training data set that has 4 million cats and 300,000 dogs, right? You might be able to differentiate a cat versus a dog, but sometimes it'll call a monkey a cat because the data wasn't curated enough. So this is one of the problems, is that you have to really identify what problem you're trying to solve, build a very careful training data set to teach the algorithms to build the model around what you're really trying to see so that it can say yes or no, essentially.
In the healthcare industry, Ari and Bryan, what do you see as the gaps in kind of within those models and people not, starting out with the proper kind of code to actually reach and, be a good representation of the actual population?
Go ahead, Bryan.
So data sets and data set sizes is a big issue, or are still a big issue. National Cancer Institute has, I believe, what was termed the short read archive, and it's a set of genomic sequences for cancer, for cancer cells, and that archive is vast. It is massive. It's many, many petabytes large. So it's a big set of data, but is it big enough, and does it have enough reads of enough similar types of tumors? And then the other problem that frequently comes up is who can run a big enough data set to actually be able to make good predictions or good diagnoses. So I've got petabytes of data, and maybe that is big enough, but can every researcher out there afford to bring down a large enough set of that data, or access a large enough set of that data to be able to do useful science? That is a big problem and a big gap. Both, do I have enough data, and can I run an analysis against enough data to get meaningful results? There's a ton more, but that's one that I see pretty frequently. What about you, Ari? What do you think?
So just as a quick clarification, I think you're talking about the Cancer Genome Atlas, TCGA.
I am, yes.
Yeah,
yes,
so SRA is actually a larger genomic data set that's maintained by the National Library of Medicine, NCBI. And that has its own host of issues, which are very similar. But I think TCGA is a great example. So in order to train these deep learning algorithms to help do differential diagnostics, you have to have these really tight data sets. You have to understand what they are. And so the training data has to be really well curated. It has to be really well annotated. You have to know exactly what it is, because you can put garbage in and you're going to get garbage out. Right? This is the funny thing about something called artificial intelligence, is there's no intelligence at all in artificial intelligence, not even a little bit. Not even the language Lisp, which is meant to to describe intelligence, even that's not intelligent, right? So we're a long way from being taken over. But the challenges in these training data are exactly what Bryan said. There's so many petabytes of data, right? So everyone remembers the last hype term, big data, right? Notice we're not talking about that anymore, right? Big data, what was that? No one really knows, right? It was just a lot of data. And really what we've done is gone from it has gone from sort of the data age to the information age. Now we're trying to make sense of all this data we collected. Everyone in life sciences ran out and bought sequencers and generated petabytes and petabytes of data and shoved it somewhere, hoping that one day it'll make sense. And now everyone's saying, oh, wait, how do I dig through this haystack and find all the needles? I don't know. Machine learning, that's how it's going to go, right? It's going to figure it out for me. Did you annotate the data? No, I don't even know what it is. It's in someone's lab notebook in a desk somewhere, right? Or it's in an Excel spreadsheet, that was lost on a thumb drive somewhere, right? This happens all the time. So data is just all over the place. And the other real problem is the lack of data standards in our field, right? When you go in and you fill out a form for anything online, let's say you're applying for a credit card, right? You could look at the applications for credit cards across every credit card provider in the world, and it would be very similar. Why? Because it's well standardized in the banking industry, right? There are no agreed upon standards of data in biomedicine, none. Everyone thinks they have one. Last we counted, there's 38 different standards, and everyone thinks theirs is the best. And the problem is that everyone doesn't want to change theirs, and no one wants to convert. So machine learning is going to be real hard to do in life sciences because of that.
So I love this for pointing out all the problems. Do you guys have any of your own type of solutions to these? Obviously not the end all be all, but how would you go about, scratching the surface of maybe helping to solve some of these problems? If you had a magic wand and can control
it. Magic wand would be for the biomedical community to get together, to drop their pretenses and develop a set of data standards. Just change the culture, pull that Band-Aid off, get that done, and then develop data platforms that adhere to those standards and make data widely available and interoperable. That is the first step, I think.
Yeah, Ari, it reminds me of a conversation you and I had not that long ago. We were really talking about what you guys look at when you're working with a customer, and you talked about culture as much as any technology, and culture and how people approach things like standards for data is really one of the biggest impediments right now, and there is not a technology solution for that. Technology companies that focus on culture really have a leg up on everybody else because it is the primary impediment. The technologies themselves, a lot of them have been around for a long time. We talked about object-based storage. Object-based storage is just a type of a data storage platform that lets you store files or images, things that aren't structured like a database is. And, it's useful when you input good metadata on what those objects are. A little bit of information about what that object might be. And that goes a long way to helping actually make that data have value. But if you don't agree on what that metadata should look like or what that metadata needs to include, it's the Wild West and you can't curate that data. And like you said, good data accuracy and good data information leads to fidelity of the artificial intelligence and machine learning processes. Without it, it's just lacking. So anyway, I agree.
The metadata thing, just sort of bringing that up one level, since that sounds very meta, probably to most people who have no idea what that is. You said it. It's a tag that describes your data in some way that's useful. let's go back to cat versus dog. Okay, almost everyone calls a cat and a dog and a dog a dog, but someone might decide that a cat should be called feline, right? Or feline phalensis, its scientific name, or C for cat, so C and D, right? And it's not labeled anywhere where that is, right? And maybe they break it into subbreeds or types or genetics or whatever, and they made up their own rubric for how they're labeling these things, and no one else knows what that is. Maybe they don't know that's a cat, right? And a computer certainly won't. So that's the metadata we're talking about.
That makes sense.
Yep. Excellent point. And I have a terrible habit of bringing up these terms and not describing them, which may be one of the other fundamental issues that we face, especially in the healthcare life sciences arena. It's just, again, precision around the language and what you're talking about.
Yeah, exactly. But so bringing this sort of back to the beginning, why is everyone so into this, right? Because deep learning actually does have a lot of promise, and it is doing a lot in biomedicine in really good ways. So COVID is a great example. Okay, contact tracing. Everyone's heard that word now. I don't know that anyone actually knows what it means. Okay, but contact tracing is a subset of medical epidemiology, which is basically tracking how a disease is a disease is progressing. And since we're in the middle of this pandemic, hopefully on the end, but it's not clear yet, we have to really understand the movement of this virus and the mutations of the virus and who it affects and when it affects them. And, with these new variants that are quite a lot more infectious, that don't require as much contact time to get the disease, you need to be able to get people quickly. If they've been exposed and they don't know it, it takes 3 days to show any symptoms at least. It can take 3 to 7 days with this virus, right? So we have to be able to track people down. So they started using machine learning algorithms to define the patterns, right? One of the things that was done during the Ebola outbreak in West Africa about 12 years ago was to track cell phone locations, because everyone's carrying a phone. So if you can track the contact that was named by someone else and find where they are real fast just by using a locator on the phone, then you can track this much more carefully. And in fact, cell towers keep a log of which cell towers they've been attached to, so you can really narrow it down. And using machine learning, you can develop an inference model that says, okay, in these situations, the contacts usually do this. So when you sat at a restaurant after 7 p.m. on a Tuesday, after the restaurant, 40% of the people go home, 40% of the people go to another bar, and 20% of the people just wander around aimlessly, right? And so you can build models to help find these people before they infect other people and quarantine them. So that's an example. Another one is diagnostics, pathology. It's quite a field, more so than I think most people realize. But pathologists sit there and look at these multi-gigapixel images on really big screens that doctors send them to say, you have this disease or you don't. Super subjective. They're really good at what they do, but it's so well annotated. Those data are so well annotated that it was easy to train for almost every disease and every disease subtype. And so now they're actively using machine learning in the background of that to help identify these diseases, and the pathologists are verifying now. So there's some really interesting ways that this is helping.
Yeah, I mean, we've seen that with the intelligence community and a lot of the work that we've done with some of the 3-letter agencies that exist out there. They do natural language processing, and some of this stuff, and this frankly is another, it's a pro and a con, because some of the ethics haven't caught up with some of the capabilities. But you have these agencies that are able to collect bulk data from social media sites and analyze the language used to determine whether or not there's, in air quotes, chatter that may be indicative of an attack. And that kind of artificial intelligence or machine learning is hugely beneficial to societies. It prevents outrageous attacks against, society at large. The flip side of that is, how much of this monitoring are we willing to tolerate, and what are the trade-offs? But that's a great example of applied machine learning that is very impactful to your everyday life, though you may never see it either. And quite honestly, that plays into some of the questions around the ethics of these types of programs. If you never see the result, how valuable is the program? So these are part of the deeper questions that we have to ask ourselves. But again, it's a great example of societal benefit.
I'm glad you brought up AI ethics, because it's a much, much larger problem than I think people know. Simple things like facial recognition, right? Your iPhone can unlock with your face as long as you're a white person. So it doesn't recognize the contrast as much because it was trained by people who, weren't thinking about the depth of the data set. To be able to do something like that. And so, there's a lot of deep ethics to really consider around this, to make sure that the use and the application of all these different artificial intelligence methods are ethical and equitable, and don't make people's lives harder, hopefully. So that's interesting.
I feel like that's not even ethical. It's not doing its job properly if it can't, recognize every, different ethnicity, every different person, like, in the world. Like, it can't do its job if it's at its, core has an issue with the original data, because it's learning from what we're giving it. But if we don't give it the right, subset of data, and like you said, it can't recognize certain people, or if there's any change, then it's not doing its job.
There's a trainer's bias.
Yeah.
And, I never thought of that until just recently, that the system itself it carries the biases. I don't know if that's the right word, carries the bias of the trainer.
Absolutely.
And again, it just, you look at these systems, they have great promise. We're really on the forefront of what they can truly do. And we don't have a great understanding of where that bias may or may not come in, and how that can substantively impact equity as well as equality. And those are things that need to be discussed, especially in areas like healthcare and life sciences, because those are fundamental. If you don't have access to equitable care, you can't participate in society equally. And that's a big deal. So looking at the link between that and technology is something that has to be done, I think, not on a common basis, but consistently, and re-examined over and over, like you would refine a model for machine learning. The same thing, we have to refine the model for the ethics as well.
And it's really important. I mean, you bring up trainer's bias. Some of that bias is unintentional. It's just how they are. But some of it is absolutely intentional. And we're seeing a unsettling uprising in that kind of cultural bias throughout the United States, and actually the world in a lot of ways. And that it's really important, especially in biomedicine, as you said, that everything is equitable for those reasons. And it also points out, I think, another thing that I wanted to bring up, which is that deep learning isn't the answer for everything. And the largest spinning of wheels that I see right now, pun partially intended, is autonomous vehicles. Someone somewhere decided that deep learning was the way to teach a vehicle to drive without a human. Here's the problem with that. How many hours a year do you think humans drive? It's in the 10 to 15 billion hours range. Okay. And how much of that is entirely reproducible? Probably about 80%, I'd say, in most environments. In total, all the companies doing this autonomous driving data collection have collected about 12 million hours of video from driving, right? This is a large order of magnitude less data than what actually happens, right? Which if it takes that 20% of unperceivable differences and inflates it by an order of magnitude. You almost cannot train a data set to cover something as important as driving, right? It may not recognize the person crossing the crosswalk. There's also ethical biases there, right? And that's happened before. Autonomous vehicles have hit people in crosswalks because they weren't wearing what the people that they trained on were wearing. So it didn't recognize it as a person. And so it isn't the answer for everything, yet they are bowling ahead of this. There have been giant AI supercomputers, big quotes, built to handle just this and to collect. They've collected half an exabyte of data, right? And for those of you who don't know what that means.
Thank you, Ari. I was about to be like, and can you describe an exabyte?
Most people know what a terabyte is, right? Most people's personal computers at least have a terabyte of storage on it. Most people know what a gigabyte is. Your phone has about 64 gigabytes or 128 gigabytes of storage on it. It's a lot. You can store your entire music collection, a bunch of movies, and every cat picture you've ever wanted on that, right? So a terabyte is 1,000 gigabytes, right? A petabyte is 1,000 terabytes, and an exabyte is 1,000 petabytes. So what we're talking about here is 500 petabytes of data. That is an astounding amount of data. It's video. It's all video collected from cars driving, but it's an order of magnitude too small to make this problem work.
Well, these are awesome topics, and I'm very excited that this is just our first podcast, and I feel like, as you guys can see, we like to poke holes in all the new buzzwords, but I think it's a lot of things people need to take a step back and look at and realize that before you just jump into all these trends, you really need to realize kind of what's behind them. What do you need to think about? Just like all the data that's not accurate. We need a lot more data sets, or just what could we do? What could other people do? Or just get people to start thinking, how can we make this the technology successful and as successful as possible? Because if we can't keep up, and if we don't make it as accurate as it can be, like you said, in the cars, or just facial recognition, just small things like that, we won't be successful in just the day-to-day healthcare, on the DoD side for defending ourselves, and just multitude of other different topics. So just kind of getting to the base of the issues and kind of talking about it. But you guys have been awesome, and I really appreciate it. And I hope everyone else has enjoyed this little more casual note.
Thank you very much.
See you next month.
See you next month.
Yep, indeed.